Hello students, we are starting with our unit number 6, that is about the lecture 3. So in this lecture we are taking about the Gibbs phenomena. So Gibbs phenomena is nothing but a special phenomenon in which we will take a finite duration signal for the finite duration signal for finding the videos, finding the FIR signal. Okay, so in this Gibbs phenomena we are taking one low pass filter. So you can see here from 0 to omega c, so those low frequency signals are passed, so it is called as a low pass filter signal. If we are taking the inverse Fourier transform of this signal or converting the frequency domain signal into the time domain signal, so we know the time domain signal or the inverse Fourier transform of rectangular signal is always a sinc function. So we are getting the HD of n signal. So in the right side we had taken all the signals in the time domain, and in the left side we are taking all the signals in the frequency domain. If as we want a finite duration signal, so here you can see the signal, that is minus m minus 1 by 2 to m minus 1 by 2, that is nothing but the finite duration signal. So for getting this finite duration signal, we will multiply a specific window of the finite length, okay, to the hd of n signal, because hd of n is nothing but the time domain sinc signal, and it is the range minus infinity to plus infinity. Okay, so for getting a finite signal, we will multiply this hd of n, that is the infinite signal, with a finite specific window signal. So from minus m minus 1 by 2 to minus infinity, the value of the signal is nothing but 0. Okay, from m minus 1 by 2 to plus m minus 1 by 2, we are getting signal, multiplied signal as it is. Okay, and again from m minus 1 by 2 to infinity, as there is no signal present in the window, so multiplication is taken as a 0. Okay, so in the right hand side time domain signal, we are multiplying the hd of n signal with the w of n signal, so that we are getting the h of n signal. But in the frequency domain, you can see that the window function is again taken as a rectangular format. So if we had taken again the Fourier transform of this signal, so what is the Fourier transform of the signal? That is the that is nothing but the sinc function. Okay, so in the frequency domain, we are taking the convolution of the two signals to get the final signal. Okay, so hd of e to the power j omega is multiplied with w of e to the power j omega, so we are getting a convolution of these two signals in the frequency domain. So here you can see the multiplication we are getting in the two format. At the 0 point, we are getting the value that is called as a main lobe. Okay, and at the two side points, the peak overshoot is given at both the points, so it is called as a side lobe. Okay, so you can see how we are getting this peak overshoot diagram. So we will take this diagram at the next point. Okay, so we are getting this type of the signal in the convolution of the two signals. Okay, so you can see how we are getting the convolution of these two signals. hd of n, it is get shifted, so we are getting the multiplication of the convolution of these two signals. Okay, so now you can see, if we are taking this is called as a main lobe. Okay, and this is nothing but the side lobe, okay, which is at the side point. Okay, so this width, you can see this peak overshoot width, it will get determined by the width of the rectangular window, that is the hd of e to the power j omega. Okay, so if width of this window is large, then we are getting the peak overshoot or the side lobe maximum. If the width of the hd of e to the power j omega is small, then we are getting a small peak overshoot, or we are getting a small side lobes at this point. Okay. Okay, so you can see if the width of the m equal to 4, so we are getting the main side lobe that is very small. If m equal to 10, so we are getting the width of the main lobe as a very large. Okay, so again, as we had taken the this as a window function. Okay, so w of n is taken as a window function. So standard, there are total 3 window functions are present. So first window function is nothing but, the first window function is Hamming window. Okay, so we can take the value of Hamming window, that is given for 0.54 minus 0.46 cos of 2 pi n divided by n for this value of n. Okay, then second one is the Hamming window. Okay, and third one is the rectangular window, which is not covered in this slide. So third window is nothing but the rectangular window, which is w of n equal to 1 for 0 less than n less than equal to m, and 0 otherwise. Okay, so we are using these three types of the window for solving the problems. Okay, so by using again these three windows, rectangular window, Hamming window and Hamming window. Okay, so if the size of the main width lobe is also given in the problem, so with the size, with this size, we can again design, check our window which is given to you. Means only not the rectangular window, Hamming window or Hamming window is given, the size of the width of the main lobe is also provided, as well as the minimum attenuation in sideband is also provided. So by checking these values, you can see which window is given for solving the problem.